This is the homework for 647 and 648. In problem 647, we need to rewrite the first equation in y equals form, then solve the system of equations. So we want to use the equal values method. And remember, we want both equations in y equals form. So this first equation is not in slope-intercept form. So we're going to go ahead and put that into y equals form. So we're going to solve for y. So first we're going to get the x to the other side. So inverse property of addition is subtraction. We subtract x from both sides of the equation. This creates a zero pair. What you do to one side, you do to the other. And so now we have negative 2y equals, and it had negative x, but I put a 1 in here, and you're going to see in a moment why I made it negative 1 instead of just negative x. I'm not changing the value, and then plus 4. And I put the x term first because remember we wanted it in y equals mx plus b form. So the reason why is because this is multiplication and I'm going to divide both sides by negative 2. This created the giant 1. Negative 2 divided by negative 2 is 1. And here is the reason why I put the 1 here, because negative 1 divided by negative 2 equals a positive 1/2. A negative divided by a negative is a positive. And then 4 divided by negative 2 is negative 2. And so now I have it in y equals form. So now here is the equations written as a system. And since I have both of them in y equals form, if this is what y equals for this, I can plug it into this equation because I need to know what's the value of y. Well, y equals 1/2 x minus 2. So I plug it into the equation, and now I have 1/2 x minus 2. That's where y, where did I get this value for y? From this equation. So now I'm going to go ahead and solve for x. And I'm going to do that by adding x to both, 1/2 x to both sides. I'm going to get x to the side that has a greater value. Well, 1/2 is greater than negative 1/2. So this creates a zero pair. And then 1/2 x plus 1/2 x equals 1 whole x. If you have a half plus a half, that equals a whole. So you can have 1x or just x. And we still want to get x by itself, so we're going to add 2 to both sides. This created a zero pair. And now I have 4 plus 2 equals 6. So x equals 6. So that's one part of our solution to our system. We found the value of x, but now we need to find the value of y. And so I can plug x back into either of these equations. And it doesn't matter which one I plug it into. So I chose y equals 1/2 x minus 2. So instead of x, I substitute 6. And half of 6 equals 3. 3 minus 2 equals 1. So I get y equals 1. So the solution to this system of equations is 6, 1. Well, what does that mean? What that means, 6, 1, is the only x and y value that will make both of these equations true is 6, 1. 6 for x, 1 for y. And the great thing about equations is once you have a solution, you can plug it back in. And for systems, you want to plug it back into both equations. But right here, I'm just showing you an example of plugging it into one of the equations. And so we have x minus 2y equals 4. So x equals 6. Y equals 1. So we have negative 2 multiplied by positive 1 is negative 2. Remember, you have to follow order of operations. And then 6 minus 2 is 4. So 4 equals 4. So that is true. That's a true statement. And you would want to go ahead and plug it back into the other equation too, because just because it works for one of the equations in this system doesn't necessarily mean it's going to work for both. For problem 648, solve the system of equations at right using the equal values method. So in order to use the equal values method, we want to put both of these equations in y equals form. So I will let you know that eventually we'll use other methods to solve this system. And the equal values method is not the most efficient way to solve this system, but for now, it's the only method you know. So we're going to go ahead and solve by setting them up into both y equals form. And so here are the two equations. And I'm going to go ahead and get y by itself. So I'm going to subtract x from both sides. And then on this equation, I'm going to add x to both sides. 0 pair, 0 pair. And then now I have 2y. I want to get y by itself. So inverse property of multiplication is division. So I'm going to divide each term by 2. And then on this side, I'm going to divide by 3, creates the giant 1. And I'm going to divide each of these terms by 3. So now I have y by itself. And here I have negative x, or negative 1x, which simplifies to negative 1/2 x. 14 divided by 2 is 7. 3 divided by 3 is 1. Multiplied by y is y. And then here, I could put a 1 here for a placeholder. 1x is just 1x. And so 1 divided by 3 is 1/3 x. And 26 divided by 3. And I'm going to leave this as an improper fraction, since I have a common denominator here. And I'm going to use the fraction buster eventually to get rid of that. So now I have my system of equations, and I have them both in y equals mx plus b form. And so y equals negative 1/2 x plus 7. So if that's what y equals, I can plug it into this equation. Because here I have y. Well, what does y equal? It equals this. So I can plug it in. So now that allows me to set these two equations equal to each other. Now what I need to do is use the fraction buster to eliminate the denominators. And we do that by multiplying each side by the least common multiple of 2 and 3. And remember, multiples of 2 are 2, 4, 6, 8. Multiples of 3 are 3, 6, 9. So the least common multiple of 2 and 3 is 6. So I'm going to multiply the left side of the equation by 6 and the right side of the equation. Remember, you have to do each term on both sides. So 6 multiplied by negative 1/2 is negative 3x, or 6 divided by 3 is 3. 3 multiplied by negative 1 is negative 3. And then 6 multiplied by 7 is positive 42. 6 multiplied by 1/3, 6 divided by 3 is 2. 2 multiplied by 1 is 2, so it's 2x. 6 divided by 3 is 2. 2 multiplied by 26 is 52. So you divide with the denominator. 6 divided by 3 is 2. And then you multiply that by the numerator. Now we want to get x by itself. So we move the variable to the side that has a greater value. 2x is greater than negative 3x. So we're going to add 3x to both sides. 0 pair. 2x plus 3x equals 5x. Still don't have x by itself, so we need to move this term over to the left side. Inverse property of addition is subtraction, so we subtract 52 from both sides. 0 pair. 42 minus 52, we have more negatives than positives, so we know it's going to be a negative value, and the signs are opposite, so you subtract. 52 minus 42 is 10, so it's negative 10, because you have more negatives than positives. Inverse property of multiplication is division. Divide by 5 because it creates the giant 1. What you do to one side, you do to the other. And we have negative 10 divided by a positive 5, which equals negative 2. So x equals negative 2. Now, when you're solving a system, the solution is the x and y coordinates. So we've solved for x. Now we have to solve for y. And we can go ahead and plug back x into either of these two equations. And I'm going to go ahead and plug it back into this first equation, x plus 2y equals 14. So here we have x equals negative 2. Here's the equation that I chose. And again, it doesn't matter which one. So instead of x, we're going to substitute negative 2 because that's what x equals. And then now we're going to solve for y. So we're going to add 2 to both sides, 0 pair. 14 plus 2 is 16. Divide by 2 creates the giant 1. What you do to one side, you do to the other. And so we get 16 divided by 2 is 8. So y equals 8. So our solution to this system is negative 2, 8. And what does that mean, negative 2, 8? It means that if I plug in negative 2 for x and 8 into y for both of these equations, it's the only solution that will make both of these true.